Let's talk about a feeling every single one of us has had, but that almost everyone gets wrong. We're going to dive into the truth about turning.
You know exactly what I'm talking about, right? You're in a car, it takes a sharp turn, and bam, you feel like you're being slammed against the door. It feels like a genuine, powerful outward push.
And for ages, we've had a name for this feeling: centrifugal force. It's that mysterious outward force that only seems to pop into existence when you're spinning or taking a corner.
But what if I told you that force isn't real at all? That it's a complete phantom? What if that feeling is actually your body trying to tell you something totally different about how motion really works?
Okay, so let's get into it. First up, the outward push myth. We're going to break down why that feeling you get in a car, while very real, might just be, well, lying to you.
The real player here, the thing actually causing that sensation, is something called inertia. It's a fundamental rule of physics. Basically, your body wants to keep going in a straight line, always. So when the car suddenly turns, your body just tries to keep going straight. It's not you being pushed out. It's the car door getting in your way and pushing in on you.
So if there's no force pushing you out, then what in the world is making the car, and you for that matter, actually make the turn? Let's introduce the real hero of this whole story.
That hero is called centripetal force, and the name literally comes from Latin for center seeking. That's exactly what it does. It's not a push-out, it's a constant pull in, yanking an object out of its straight-line path and forcing it into a curve.
Now here's the really cool part. Centripetal force isn't some brand new magical force of nature. Think of it more like a job description. It's a role that other forces we already know, like tension in a string, or the pull of gravity, or even the friction of tires on a road can take on.
But why do we even need this inward force? I mean, what's the big deal? To get that, we have to look at what it actually means to turn from a physics perspective. And it all boils down to one super important difference. You know, in everyday life, we throw words speed and velocity around like they're the same thing. But in physics, nope, they're different. Speed is just a number, how fast you're going. But velocity is speed plus direction. So 20 meters per second north, that is a velocity.
And here is the absolute key to everything. Since velocity includes direction, if you change your direction, you are by definition changing your velocity, even if your speedometer doesn't budge an inch. And what is a change in velocity? That right there is the very definition of acceleration. And as Newton taught us, acceleration always requires a force. So that force that's making you accelerate by turning, that's our hero, the centripetal force.
All right, so this isn't just a bunch of textbook theory. This stuff is happening literally everywhere, all the time. Let's start spotting this inward force out in the wild.
Let's jump back into that car for a second. The thing that's turning is the car, obviously. But what's the force pulling it inward? It's the friction between the tires and the asphalt. That's it. If you've ever hit a patch of ice, you know exactly what happens without that friction. The car's inertia takes over, and you just keep sliding straight ahead. Or picture this, you're swinging a ball on a string around your head. The ball isn't trying to fly outwards. The string is constantly pulling it inwards, forcing it to move in a circle. In this case, the tension in the string is playing the role of the centripetal force. Now, let's take this to the next level, because the exact same physics that explains a turning car is also what keeps a roller coaster glued to its track and, get this, would keep satellites circling the Earth. Ever been on a roller coaster loop and wondered, how are we not falling out right now? Well, when you're upside down at the very top, you have two forces pulling you inward, toward the center of the loop. The track pushing down on the wheels and gravity pulling you down. That combination is your centripetal force. Go any slower, and gravity takes over, and well, you'd fall.
And this is what's so mind-blowing about physics. It's universal. For that ball on a string, the center is your hand, and the force is tension. For a satellite zipping around our planet, the center is the Earth, and the force is gravity. It is the exact same principle, just scaled up from your backyard to outer space.
And the speeds we're talking about are just insane. To stay in a stable orbit about 7,000 kilometers up, a satellite has to be moving at over 8 kilometers every single second. That's the magic speed where Earth's gravity provides the perfect amount of inward pull to keep it from flying off into deep space.
And just to put that into perspective, at that blistering speed, it completes a full orbit around our entire planet in roughly 90 minutes, all because of that constant center-seeking gravitational pull. So, there you have it. We've busted the myth of the outward push,
and we've found the real inward pull. And once you see it, you start to see the world a little differently. It gives you a whole new lens for looking at anything that turns.
So, here's a little mental toolkit for you. The next time you see anything moving in a circle, a car, a kid on a merry-go-round, whatever, do this. First, completely ignore that feeling of being pushed out. Remember, that's just your inertia talking. Instead, ask yourself one question. What's pulling it in? If you can find that inward force, boom, you've found the centripetal force.
And that brings us, pardon the pun, full circle, back to you in that car. That force you feel isn't some invisible thing shoving you sideways. It's the very real, very solid car door pushing inward on you, fighting your inertia and forcing your body to accelerate into that turn right along with it.
So the next time you take a turn, you'll know the secret. It's not about being thrown out, it's about being pulled in. And that kind of makes you wonder, doesn't it? What other invisible inward forces are out there quietly shaping the motion of everything around us?